A linear function is graphed below, and the table of points for the function is given. So basically, this table and that graph are describing the same thing. The points on this table are the same as the points on the graph. We're being asked to find and label the y-intercept on the graph and on the table. Okay, if you watched the last video, finding the intercepts on the graph should be easy. For a y-intercept, I look at my y-axis, crosses my function right there at 4. Now that I know that 4 is my y-intercept, it's easy to see on the table that this is my y-intercept. We kind of cheated. First we found it on the graph, and then we found it on the table. But how would we know which of these points was the y-intercept if we weren't blessed with this table right here? I mean, with this graph. Well, remember in the last video, the special thing about intercepts is that they have a 0. This point has a 0, so we should be suspicious that it's the y-intercept. But why not pick this one? This one also has a 0. How are these two different? Well, I'll tell you. They're both intercepts because they have a 0. But I know this one's the y-intercept because that value right there, 4, that's a y value. Y-intercepts have y values. This point, it has a 0, so I know it's an intercept. And it has an x value, so I know it's an x-intercept. And sure enough, if we look over here on the graph, 2 is indeed our x-intercept. So that's the secret. It's the profound truth. Intercepts have 0s, y-intercepts have y values, x-intercepts have x values. So you're going to use that to answer the questions below. Let's see them. Okay. So I gave you a whole bunch of tables. Some are vertical and some are horizontal, but it's the same idea. Remember, if you're looking for an x-intercept, you're looking for 0 on the table, and you're looking for the x value to be 2. You can do this. Good luck.